Hello everybody. Welcome again to another interesting video on quantitative aptitude from CareerRide.com. Our topic for today is arithmetic progression. And as all of you know, arithmetic progression or AP is a very important topic when it comes to your placement tests or entrance exams. Because in almost all the papers, you will find at least 3 to 4 questions being asked from this chapter if it is a big paper format. So in today's video, we are going to learn this chapter in a very easy manner, and we'll see a lot of variety of questions here. And I really hope that after watching this video, you'll be able to solve the questions from this chapter in a very easy way. So let's begin. Okay, so let us begin the chapter with some basics. Now suppose a series of numbers is given to you, A1, A2, A3 up to AN, for example, let us say, and you want to find out whether this given series is an AP, that is an arithmetic progression, or not. So now many of you would know that the most important condition and the only condition that a series to be in AP is that the difference between the consecutive terms should be equal throughout the series, which means A2 minus A1 should be equal to A3 minus A2, and this should continue throughout the series. That is, the difference between the consecutive terms should be same. Now A2 minus A1 is equal to A3 minus A2, and this is happening for the whole of the series. So I call this difference between the consecutive terms to be common difference, that is CD common difference. Okay, and we denote it by D. Common difference is D here. Okay. Now suppose I am given that the first number of a series is, let us say, A. Okay. In that case, if D is the common difference, what is going to be my second term? My second term would be A plus D. What would be my third term? My third term would be A plus 2D, right? Because the difference is increasing by D, that is the common difference, right? So the third term would be A plus 2D. My next term, that is the fourth term, would be A plus 3D, and this will happen for the whole series. Now, are you noticing something interesting here? The interesting thing to notice here is when I'm writing my second term, it is A plus 1D. That is the first term plus the common difference. My third term is A plus 2D. My fourth term is A plus 3D. Now, if I go in a similar fashion, my nth term would be, an would be what? It would be A, that is the first term, plus n minus 1 into the common difference, right? It's quite clear from the series that we have written here. Okay, so that is exactly what I've got here. My nth term, that is an, is equal to A plus n minus 1 multiplied by the common difference D. This is a very important thing that you will use almost in all the questions of AP. So make sure that you understand it very clearly and you remember it also. Okay, let's see more. Okay, so we just saw that the nth term, that is an of a series, is equal to A plus n minus 1 into T. Now, can I try to rearrange the things a little here? Of course I can. So can I write n minus 1 multiplied by D is equal to an minus a, and I can further simplify it to write it as n is equal to an minus a upon D plus 1. Now if I try to see the description of each of the items here, I see that, look at the right side, n is equal to total number of terms in the AP. A is my first term, an is my nth term or the last term of the series, and D is my common difference. And now from here I get n is equal to, that is the total number of terms in a series, is equal to, if I have the last term, I can subtract the first term from it and divide it by the common difference plus 1. So if I want to find out the total number of terms in a AP, it is as simple as last term minus first term divided by D plus 1. Again, a very important thing that you will use throughout the chapter, and I would highly recommend that if you find yourself stuck at any point of time during the video, make sure that you pause the video there itself and take a good look at the slide. Okay, you will understand most of the things then in there itself. Okay, let's move on. Okay, so now let's try to do an example based on whatever we have learned till now. Now suppose I'm given a series 1, 3, 5, 7 up to 15, right? And I'm required to find out the total number of terms in the series. Okay. So now I just saw that n, that is the total number of terms in a series, is equal to last term. My last term is 15 here, minus first term, that is d, and that is 1, divided by d, that is the common difference. What is the common difference here? 3 minus 1 is 2, 5 minus 3 is also 2, 7 minus 5 is 2. So my common difference from here comes out to be 2 plus 1. That is the number of terms, right? So what is it? It is 14 upon 2 plus 1, that is equal to 8. So I have got 8 terms in this series, right? Now let us cross check it. It means that my eighth term should be 15. Let us try to find if that is the case or not. My first term here is, I know that my nth term is equal to a plus n minus 1 into d. So my eighth term should be equal to a plus, a is what? A is 1. The first term is 1. N value is 8. My eighth term, 8 minus 1 multiplied by the common difference 2. That is equal to 1 plus 14. That is equal to 15. Now both these things tally. My eighth term from here is 15, which actually is 15. And if I try to find the total number of terms in the series, it is also 8. It means whatever we have learnt till now, we are able to apply it also. Okay, with the help of this easy example. Let's see more. Okay, now the next important thing that I'm going to use throughout the chapter on arithmetic progression is finding the sum of a series that is in AP. Okay, and let's see how to do that. Suppose I'm given a series, an AP series, whose first term is A and the common difference is D. So my series becomes A plus D, A plus 2D, A plus 3D up to A plus n minus 1 D. There are n terms in this AP and I'm required to find the sum, that is sum of n terms here. Okay. So how can I do that? What I'll have to do is I'll just add all the terms. So I'll put a plus sign between all the terms, right? This is what I'll do. From here, can I try to rearrange this series? Yes, I can. What can I do? I can just take out all the A's out first. How many A's are there? There are n terms. So there are A plus A plus A. How many times? N times. So I get this. Now the second part of the series in this case becomes, I'm left with D's. So the second term has 1D, 2D, 3D, up till where? Up till the nth term. And what is the nth term? N minus 1. Here I have n minus 1 D. So now you can see that if I try to further simplify it, it becomes A n times is NA, right? And if I try to simplify this, the second part of the series, that is the D's part. So what do I get here? It is nothing but, you can see it is 1 plus 2 plus 3 plus up till n minus 1, and I can take D common here. I can take D out here. What is this? This is nothing but the sum of natural numbers up till n minus 1. So I can write it as n into n minus 1 upon 2 D, right? This much part I can write like this, right? So what do I get finally? I get NA plus n into n minus 1 D upon 2, right? This is the sum of the series. Now if I try to simplify it, what do I get? I take n by 2 common and I get n by 2 into 2A plus n minus 1 into D. So this is actually the formula for the series with n terms in AP. Okay. Now see, I can directly give you the formula, but the reason I'm trying to explain you everything in steps is because I don't want to remember you anything. I just want that once you understand it and it gets imprinted on your mind. You will not have to remember anything if you understand it properly. Okay. So now if we go a step further, we can see that I can further try to simplify this. I can try to break this formula of sum of n terms. I can write n by 2 and I can write this A as A plus A, right? So it becomes A plus n minus 1 into D, right? So this is what it becomes. And we see that we can write it as n by 2 into this A is what? This is first term, and what is this? This is the last term, right? This is the last term. So my formula becomes very simple in this case, and it becomes the sum of n terms of a series is equal to n by 2 into first term plus last term. So these are the two things that are there in the box, blue box at the moment, that you have to actually apply in all your questions almost, right? And once you understand both these things properly, it will become very easy for you to apply them. Otherwise you will have to remember them. So make sure that you understand them well, right? If you are stuck, as I said earlier, pause the video here, take a good look at this slide, and I'm sure you'll get it very easily. Okay, now the next important thing in this chapter is arithmetic mean. We denote it by AM. So let us first of all see what is arithmetic mean. Suppose you are given an AP series and it is A, B, C. This is a series with odd number of terms in it at the moment. Okay, the example I'm taking is an arithmetic series with odd number of terms. Okay, so now here the middle term, that is B, is your arithmetic mean here. Okay, and how do you calculate it? You calculate it by B is equal to A plus C by 2, right? So this is your arithmetic mean here. Now suppose I have got a series of A1, A2, A3, and similarly I go on till n number of terms. Okay, so what is going to be the arithmetic mean here? The arithmetic mean here would be A1 plus A2 plus dash 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 till n divided by n, right? This is the arithmetic mean here. Okay, now there will be questions where you may be given the first term and the last term, and you might be asked to insert n arithmetic means between these two given numbers. So the arithmetic means that I am considering here are M1, M2, M3, so on till Mn, because I am required to insert n arithmetic means here, right? So first of all, what do I need in this case? I need the common difference. So the common difference D in this case here is B minus A upon n plus 1, right? So this is how I'll find the common difference here. Okay, and my arithmetic mean, my first arithmetic mean here would be what? A plus D. So A plus B minus A upon n plus 1, right? M2 would be what? M2 is equal to A plus 2D, right? So this way you can keep going on and apply and try to find out arithmetic mean of a series, or you can insert arithmetic means between two given numbers of a arithmetic progression. Okay, quite easy, nothing difficult here. When we solve the questions, you will find it even easier. Okay, now moving ahead, let me try to get your attention to some of very interesting and important things about an arithmetic progression. And knowing these things would mean that you will be able to solve many questions absolutely directly without any calculations. Okay, so the first important thing to know here is, if you add or subtract a particular number from all the terms of an AP, the resultant is again an AP. The resulting series would again be in AP. Now let's see with an example. If I'm given a series like 1, 3, 5, 7 for example. Okay, so these are the terms. Now let me try to add a same number to all the terms of this series. Let me try to add 2 to each of the numbers of this series. Okay, what would be my resultant series? My resultant series would be something like 3, 5, 7, 9, right? This will keep going on. Now see the common difference here again. The difference is 2, the difference is 2, the difference is 2. Since the common difference is 2, the resulting series is again in AP, right? Isn't it interesting? Now if you know this, you'll be able to solve many questions directly, right? Now let's see another interesting thing here. Similarly, the way you added and subtracted things, if you multiply or divide all the terms of an AP by a constant, the resultant is again an AP series. Okay, again let's try to see this with the help of an example. Okay, again I'm trying to multiply all the terms by 2. Okay, 2 multiplied by 2 multiplied by 2 multiplied by 2. What do I get here? 2, 6, 10, 14. Okay, now for a series to be in AP, the common difference has to be same throughout, right? So the common difference here is 4. Here also it is 4. Here also it is 4. So this proves that this series is also an AP, and whatever I have written here is correct. Just knowing these important things will help you solve many questions directly, as I said. Okay, so just try to keep these in your mind. Okay, now let me show you one more interesting thing, and it is, if you add two series that are in AP, if you add the terms of those two series, the resultant series that you get will again be in AP. Let me try to show it to you with the help of an example. Suppose my series 1 is 2, 4, 6, 8 with a common difference of what? Common difference of 2. Okay, and my series 2 is 3, 6, 9, 12 with a common difference of 3 here. Okay, if I try to add the terms of these two series, what is going to happen? I'll get my third series, and the terms will be something like 2 plus 3 is 5, 6, 4, 10, 9, 6, 15, 20. Similarly, it will keep going on. Now if you notice, the common difference here becomes 5, 5, 5. If the common difference is same throughout the series, it is an AP. It means the resultant series that I'm getting here, my S3, is again in AP. Another interesting thing, another important thing that you must pay attention to. Fantastic. So let's start with some questions now. The initial questions that we take up will be little easier ones so that your momentum gets built up, and as you get into the rhythm, we'll move on to more difficult questions gradually. Okay, so let's see the first question here first. If third and seventh terms of an AP are 19 and 29 respectively, find its first term. Very, very easy question. The seventh term that is given to us is 29. The seventh term of an AP can be written as A plus 60 is equal to 29, right? The third term can be written as A plus 2D is equal to, it is given to us as 19. Now, can I subtract the second one from first? Yes, I can. So, it becomes 4D is equal to 10. That is what I get from here. It means my D is equal to 10 upon 4. That is equal to 2.5. Can I place this value in my equation? Yes. It is given to me that A plus 2 into 2.5 is equal to 19. It means A plus 5 is equal to 19, which gives me A is equal to 14. So my first term here is 14. Easy, isn't it? Let's move on to the second question. Question number 2. Fifth term of an AP is 7. Fifth term of an AP is 7, while seventh term is 17. Which of the following is its nth term? Looks difficult, but don't worry. It is a very, very easy question and you will be able to solve it very, very easily, because I'm going to give you a very simple trick here. And the trick here is, rather than solving this question by steps, try to use the options given to you. Try to use the options and see which one satisfies. Okay, so let us begin with 8n minus 30. Okay, so if my fifth term is 7, it means 8 into 5 minus 30 is equal to 8 5s are 40, that is equal to 10, which is not equal to 7, which means my first option doesn't satisfy the given thing, which means I'll not go further and check anything more, because in the first step itself it fails me. Let me go on to check the second option. The second option given to me is half of 10n minus 36. Can it be the nth term? Let's try to see if it satisfies the condition for the fifth term. Okay, so 1 by 2, fifth term is n is 5 here, minus 36. This is equal to half of 10 5s are 50 minus 36. This is equal to half of 14. This is equal to 7 and my fifth term given is 7. Oh, fantastic. This option seems to be satisfying the conditions that I'm given. Okay, so it satisfies the conditions for my first term. So let me go to the next step and try to see if it satisfies for the second term also or not. Okay, the seventh term here is what? Seventh term is n is 7 minus 36 is equal to half of 70 minus 36. This is equal to half of 34. This is equal to 17, and that is my seventh term. Oh, fantastic. Again, it satisfies my condition for the seventh term also, which means that the option 2 given to me, that is half of 10n minus 36, satisfies the conditions for both my fifth term and the seventh term. So this is my correct option. If you go to solve the question step by step, it will go very lengthy and it will consume a lot of time. So it makes more sense to make use of the options given to you. Okay, let's go on to the next one. Question number 3. The ratio of second to seventh term of an AP is 1:3. Fourth term is 9. Find 15th term. Also find the AM of this AP with 15 terms. Now see, this question looks difficult, and it especially looks difficult because there seems to be a lot of information given. But trust me, this is a very easy question. All that it needs is just an application of some common sense and some simple mathematics. All that you have to do is just read the question carefully and go step by step, apply what you already know. Let's see how to do that. So it is given to us that the ratio of second to seventh term is 1/3. So the second term can be written as A plus D, and the seventh term can be written as A plus 6D, and the ratio is given to us as 1/3, right? Just I have written what is given to me in the question. So this gives me 3A plus 3D is equal to A plus 6D, which means 2A is equal to 3D, and this gives me the relation between A and D. So A upon D is equal to 3/2. Now this value is in ratio. I cannot use it as it is directly, right? From ratio and proportion I know this, but I can assume A to be 3x here, and I can assume D to be 2x here, right? Now also they will be in the ratio. If I do A by D, it will be 3/2 only. Okay. Now the next thing given to me in the question is the value of the fourth term. The value of the fourth term, that is equal to A4, that is equal to A plus what? A plus 3D. A plus 3D is given to me as 9. Can I place the value of A here? Yes, the value of A for me is what? 3x. The value of D for me is what? The value of D for me is 2x. This is equal to 9. This gives me 3x plus 6x is 9x is equal to 9. This tells me that x is equal to 1. What does this give me? It just tells me that my A is equal to 3x is equal to 3 now, because x is 1. And similarly D is what? D is 2x. So the value of D actually is 2. Now see how easy this question is. What is given to me further? It is given to me that I have to find out the 15th term. So A15 is what I have to find out. So I know that this is equal to A plus 14D, right? So this is equal to the value of A is 3 plus 14 into 2 is 28. This is equal to 31, which means my 15th term is 31, right? The first part of the question is solved, and solved very easily. Now what is the next thing asked to me? The next thing asked to me is the arithmetic mean, right? So now I know that there are 15 terms in the series, right? The first term is 3, and the last term here is the 15th term here is 31. This is a series with 15 terms, right? How many terms? 15 terms. That is odd number of terms. And whenever there are odd number of terms, the middle term is the arithmetic mean. Middle term here means what? The 8th term. 7 this side, 7 on left, 7 on right, and 1 in between becomes the 8th term, right? What is my 8th term here? A is what? A is the value is 3 plus 7D, right? So 7 into 2 is what? 7 to the 14. 14 and 3 is 17. So my arithmetic mean here is nothing but 17. My 15th term here is 31 and my arithmetic mean for this series of 15 terms is 17. Nothing else, right? Very, very easy. Very, very simple to solve. Nothing difficult here. Just take a close look at what is given in the question and start moving your pen. Question number 4. Find the value of 16th term of an AP if 6 times its 6th term is equal to 10 times its 10th term. Again, a very, very easy question. Let's see how to solve this kind of a question. Okay. Now, in this question, it is given to me that 6 times the 6th term. The 6th term is what? A plus 5D. I know from my AP is equal to 10 times the 10th term. So 10th term is A plus 9D, right? This is given to me in the question. From here, what do I get? I get 6A plus 30D is equal to 10A plus 90D, right? What do I get further from here? I get 4A is equal to minus 60D or A is equal to minus 15D, right? Now when I go to find my 16th term, how will I write it? I write it as A plus 15D, and I know that the value of A that I have gotten from the previous solving is 15D plus 15D. So what is the value of A that I get, 16th term that I get here? It is equal to 0 and nothing else. Now see, I told you this is a very, very easy question to solve. The only thing that you have to do is apply what you know, right? So use your common sense, read the question carefully and just start moving your pen and your mind. It is an application of your common sense more than your knowledge about your arithmetic progression. If I sit like a ghost without moving my mind, without moving my pen, I'm not going to reach anywhere. So the trick here is read the question carefully and start solving, right? And most of the times you will find the right answer. Question number 5. If TP is equal to A, TQ is equal to B, TR is equal to C, what is the value of A into Q minus R plus B into R minus P plus C into P minus Q? Now see, this is also a very easy question. The only thing it requires is a little bit of knowledge of arithmetic progression, and then you have to solve the algebraic equation that you get here. Okay, so pretty simple, nothing difficult here, just pay attention. Now till now what happened, whenever we wanted to write pth term, we wrote it as AP, but in certain papers, in certain questions, you may also come across TP, right? T here denotes term, P denotes pth. So pth term, okay? TQ here means qth term. TR here means rth term, okay? Now notice one more thing. The value of pth term is given to us as A. So if we take our first term to be A, then the question will become very confusing. So what we'll do is we'll assume that our first term is X. This is what the only thing that is changing here. Okay. So now let us begin solving this question. If X is my first term, then my pth term TP is equal to X plus P minus 1 into D, right? And its value will come out to be, is given as A. Qth term becomes X plus Q minus 1 into D and its value is given to me as B. And similarly happens with the rth term, that is X plus R minus 1 into D and its value is given to me as C. Okay. Now what I'll do, I'll just start placing the value of A, B and C in the equation that is given to me in the question. Okay. So the value of A from here is X plus P minus 1 into D, and the equation goes on like Q minus R, right? Plus, let's place the value of B. It is equal to X plus q minus 1 into d multiplied by r minus p plus, what is the value of c here? The value of c here is x plus r minus 1 into d multiplied by p minus q. Now just start solving the brackets. What do you get here? You get x plus pd minus d into q minus r plus x plus qd minus d into r minus p plus x plus rd minus d into p minus q. Okay. So now if I go on to solve this further, what do I get? I get qx plus qpd minus qd minus rx minus rpd plus rd plus xr plus qrd minus rd minus px minus pqd plus pd plus xp, that is px, I can also write it as px plus prd minus pd minus qx minus qrd plus qd. Now take a good look at what you have got here. Okay, because most of the terms, in fact all the terms are going to cancel out here. Okay, let's see how. Qx gets cancelled out here. Okay, my qpd, this gets cancelled out here, minus qd plus qd minus rx is going to cancel out with rx here, minus rpd is going to get cancelled out here, rd is cancelling out here, qrd is cancelling out here, minus px plus px, pd plus pd and minus pd. So you see all the terms have cancelled out here and my ultimately the answer is 0. That is why I said it is a very easy question. But if I sit like a ghost and don't move my pen, I'm not going to reach anywhere. So pretty easy question, but you have to get going. You have to move your pen to solve these type of questions, and practice is ultimately most important. Question number 6. 12th term of an AP is minus 10 and the sum of first 4 terms is 36. Find the first term and the common difference. Now how to solve this kind of a question? Pretty easy. Let us assume that our first term is A1, right? So our 12th term becomes A1 plus 11D is equal to minus 10. This is given to me in the question. Okay, I'll mark it as equation number 1. Now what else do I know? I know that if I want to find the sum of n terms in AP, if this series is to be found out, the sum, the equation is A1, the first term, plus the last term, that is A4 here, the fourth term that I want, divided by 2 into multiplied by n, that is the number of terms that we are taking, right? So in our case, this it is given that Sn is equal to 36. The sum of first 4 terms is 36 is equal to A1 plus A4 upon 2 multiplied by 4 terms we are taking, so multiplied by 4, right? So can I solve this further? I can. So it becomes 18 is equal to A1 plus A4, right? A4 is the fourth term, right? So can I write my fourth term as first term plus 3D? I can. I know this. So this becomes 2A1 plus 3D is equal to 18, right? This is the second equation that I get. Now can I solve equation number 1 and equation number 2 for 2 variables to find the answer? Let's try to do that. What do I have? 2A1 plus 3D is equal to 18. This is my second equation. My first one is A1 plus 11D is equal to minus 10. This is my first equation. So what I'm going to do here is I'm going to multiply my first equation by 2 so that I'm able to solve this, right? What do I get? I get finally, when I multiply my first equation by 2, I get 2a1 plus 22d is equal to minus 20, right? And I can just copy my equation number 2 here quickly and it becomes like this. And now can I subtract 1 from 2? Let me try to do that. This becomes minus 19d is equal to what? It becomes equal to 38. So d is equal to nothing but minus 2. The value of d I have received here. Now what do I want? I want to find the value of a. So let me place this value of d in equation number 1. So a1 plus 11 into minus 2 is equal to minus 10 is what we have, right, from equation number 1. So a1 minus 22 is equal to minus 10. So a1 is equal to 22 minus 10. This is equal to nothing but 12, right? A1 is my first term, D is my common difference, and ultimately I have solved the question very easily. Question number 7. What is the greatest possible sum of the AP 23, 21, 19 going on? Okay. So now let us first of all write this AP 23, 21, 19 and it goes on. Okay. What do we see here? We see here that this is an AP of odd numbers, right? 23 is odd, 21 is odd, 19 is odd, right? So this is an AP of odd numbers. And what is the common difference here? The common difference here is 21 minus 23 is minus 2, right? So this is a falling AP. Actually, it is a falling AP. The numbers are going down. They are decreasing. Okay. So if I want to find the greatest possible sum, it means I have to find the smallest positive number in this. And because going beyond, when the series starts getting into negative numbers, the sum will start reducing again because of them, right? So basically I'm trying to find that number which is the smallest number and is positive here. Okay. Now since it is a series of odd numbers, it means my positive number here is also going to be an odd number. And what is the smallest odd number? It can have 1 as the smallest odd number, right? It is positive also, so it will give me the greatest possible sum. So basically my question is I'm trying to find the sum of a series whose first term is 21 and whose last term is 1. This is basically my question is boiling down to. Okay. Now I know that the sum of n terms in a series is first term plus last term upon 2 into the number of terms, right? Now my first term here is 23, my last term here is 1 by 2, but I don't know what is this n, what is the value of this n. So that is what I'll try to find out and I'll place in this equation here. Okay, let us try to find out. We know that the value of any term in an AP is equal to a plus n minus 1 d is equal to the value of the term at that place. Here let us assume it is 1. So our first term is 23 plus n minus 1, n is what we are trying to find out, d we know is minus 2 is equal to 1. So this is equal to 23 minus 2n plus 2 is equal to 1. 25 minus 2n is equal to 1. From here I get n is equal to 12. So basically I'm trying to find the sum of first 12 terms here. So my Sn in this case becomes 23 plus 1 upon 2 multiplied by 12. This gives me what? This gives me 12 into 12. This is equal to 144. So this is the greatest possible sum that this series can have. If you find this question confusing, I would highly recommend that you pause the video here and just try to take a good look at what we have discussed. Question number 8. Okay. Here a series is given to you up to 60 terms and you are expected to find the sum of this series. Now, since this is a chapter on AP, the first thing we need to see here is whether the series is in AP or not. Now, this type of a question is important because this question is a little tricky. It's not difficult. It's an easy question. But if you don't know how to solve this type of a question, it might not occur to you in exam that what is happening. So it is very important that you practice and solve this type of questions well in advance. Okay. And you have to be aware that this variety of question might appear in the exam actually. Okay. So now let us rewrite the series here. 1 plus 3 plus 4 plus 5. We have rewritten the series up to 60 terms here. Okay. Now, first of all, let us check whether this is an AP or not. So 3 minus 1 is what? It is 2. This is 1. 5 minus 4, 1, 2, 0. We see that the difference between the consecutive terms is not same throughout the series, which means this series is not an AP. And if it is not an AP, I cannot apply the formula that I know. Okay. So now what is happening here? Actually, in this kind of a series, they mix two different series. Okay. Now, what are the two different series here? The two different series here are 1, 4, 7, 10 and so on. Okay. This is the first series. So, if you notice the common difference here, it is 4 minus 1 is 3, 7 minus 4 is 3, 7 minus 4 is 3, 10 minus 7 is 3. And this is how the first series is moving. The second series here is the terms that we have left. So they are 1, 5, 7, 9 and so on. So if you see, the common difference here is what? It is 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2. So you can see that there are two different series that are mixed up here. Okay. Now, how to solve this kind of a question? Should we separate out these two series and add them? So should it be S1 plus S2? Should we do something like this? But then in that case, the question becomes lengthy, right? If I want to solve this question quickly, what would I do, right? So what I would do in this kind of a question is I would start adding the terms in the pairs of 2. So first two terms I'll add 1 and 3, 4 and 5 I'll add, 7 and 7 I'll add, 10 and 9 I'll add, and I'll come across a new series. My new series would be 1 plus 3 is 4, 4 plus 5 is 9, 7 plus 7 is 14, 10 plus 9 is 19. So now you can see that the common difference here is 9 minus 4, 5, 14 minus 9, 5, 19 minus 14, again 5. So now my new series is actually in AP. This is the first thing that I have come to understand. Now till how many terms? Earlier it was 60 terms, but now there is a difference. What has happened? Understand it here. I had 1 plus 3 plus 4 plus 5. I am shortening the series to make you understand. Okay. Now if I have 4 numbers, right, and I make the pairs of 2. Okay. Now how many numbers do I have? 1 plus 3 is 4 and 4 plus 5 is 9. So how many numbers in the series now? 2 numbers in the series, 4 and 9. Similarly, if I go on till 60 terms, how many pairs would I use? I would use 30 pairs. So I would form 30 terms here now. My new series would have 30 terms. I hope this is quite clear to you, and if it is not clear to you, just replay this much part of the video and try to understand it, because this is very, very important here. Okay. So now I know that sum of the series, sum of n terms is what? It is equal to n by 2 into 2a plus n minus 1 into d. I know this formula already. What is the value of n here for me? It is 30 terms, 30 divided by 2. 2a, a is 4 here. So it becomes 8 plus n is 30. 30 minus 1 is 29. 29 into what the common difference is? 5 in my new series. What does this give me? This gives me 15 into 8 plus what? 15 into 8, 145, right? So this is equal to 15 into 155. 3 and the sum of series would come out to be 2295. I have checked it. You can check it too. Okay. This is how it will come out to be. So the question is pretty easy, as you can see. Nothing difficult here. Just a little tricky. So make sure that you pay attention to this kind of a question and you practice this kind of questions to be able to solve them in the exam. Okay. Let's move on to the next one now. Question number 9. First term of an AP is 3. The sum of first 5 terms is equal to 1 by 4 of the sum of next 5 terms. What is the 25th term? Now see, what's given to me in the question is I'm given a series of 10 terms, A1 to A10, and my first term is given to me as 3, that is A1 is 3, and it is said that the sum of first 5 terms, that is A1 to A5, let me mark it as S5, okay, and the sum of next 5 terms, A6 to A10. So let me try to write A6 to A10 in a form, and the form is, if I write the sum of first 10 terms and I subtract the sum of first 5 terms, will I get the sum of A6 to A10? Right or wrong? Right? So now, applying the relationship that is given in the question. So the sum of first 5 terms is equal to 1 by 4 of the sum of next 5 terms, that is A6 to A10. And I have written A6 to A10 sum as S10 minus S5. From this, what do we get? From this we get 4 times of S5 is equal to S10 minus S5. This means 5S5 is equal to S10. Right? Now, I know that the sum of n terms in an AP, the formula I know already. Let me try to put that formula in the equation 1. Right? So, 5 into the sum of first 5 terms is what? N by 2, that is 5 by 2, 2a, that is 2 into 3, plus n minus 1, n is 5 here, first 5 terms, so 5 minus 1 into d, right? This is equal to the sum of first 10 terms from my relationship 1 that I got, okay? So the sum of first 10 terms is what? 10 by 2, n by 2 into twice of a, that is equal to 6, plus 10 minus 1, n minus 1 is 10 minus 1 is into d, right? So what is it? If I cancel out 2 from both the sides, it is equal to 25 into 6 plus 4d is equal to 10 into 6 plus 9d. This is what I get from here, okay? Now, can I simplify it further? Yes. Let me divide it by 5. So 5 5s are 25, 5 2s are 10. So this gives me 6 5s are 30 plus 5 4s are 20d is equal to 6 2s are 12 plus 9 2s are 18d. What do I get from here further? I get 2d. 2d is equal to minus 18 is what I get from here. So the value of d from here for me is minus 9, right? Now look at the top. I want to find out the 25th term here. So my 25th term is equal to the first term plus n minus 1. So 25 minus 1 is 24 into d. D's value is minus 9 for me here. This is equal to 3 plus 24 multiplied by minus 9. This is equal to 216. Right? I have checked it already. You can do it too. So my answer comes out to be 213 minus 213. So my 25th term here is 213 with a negative sign, with a minus sign. See, quite an easy question. Doesn't it look easy? It's quite easy. All that you have to do is you have to be able to solve the equations that you get. Okay? Moving on to question number 10. Sum of 3 numbers in an AP is 18 and the sum of their squares is 158. What is the smallest number? Now see, this question is nothing difficult. It's a very easy question. The only thing is I'm going to use a trick here, little trick here. So pay attention to the trick. Now see, what happened till now was whenever we wanted to take terms in an AP, we took them as A plus D, A plus 2D, But for the purpose of this and this type of questions, what I'm going to do is I'll take the middle term as a, and I'll take my previous term as a minus t and the next term as a plus d. For now, just see this much. When I solve the question, you will understand why I did what I did. Okay. So now it is given to me that the sum of three terms is 18. So a minus d plus a plus a plus d is equal to 18. Right. Now when I open the brackets, I can cancel d and d. So I get 3a is equal to 18 and it gives me a is equal to 6. Now if I had taken the terms to be a plus d, a plus 2d, I would not have been able to cancel these d's, and this is why I took the terms like this, right? I hope you understand this. Okay. Now what is given to me in the question further? It is given to me that the sum of their squares, the squares of the term, is 158. So it is given to me that a minus d square plus a square plus a plus d square is equal to what? It is equal to 158. Okay, so can I open the brackets? Yes, just simple formula application. A square plus d square minus 2ad plus the second term a square plus opening the third bracket, that is a square plus d square plus 2ad. Right, this is equal to 158. Now from here minus 2ad get cancelled. What am I left with? 3a square plus 2d square is equal to 158. I already know that my value of a is 6. So a square becomes 36. 3 into 36 plus 2d square is equal to 158. Right? So 108 plus 2d square is equal to 158. 2d square is what? 2d square is 50. Right? And from here the value of d for me becomes what? Plus minus 5. Right? Can you understand it here till here? Pretty easy. Okay. So now what are the terms for me? It is the middle term for me is a equal to 6, that is 6. 6 minus, if I whatever value I take of d, my one of my terms, if I take minus, it will become 11 here and 1 here, and otherwise it will become 1 here and 11 here. You can place the values of plus and minus 5 both in the terms and you can try to check this out. Okay. So in both the cases my smallest term comes out to be 1. The smallest number comes out to be 1 and that is my answer. This is the smallest number when I solve this question. Easy, isn't it? Okay, let's move on to the next one. Moving on to question number 11. What is the sum of numbers in the nth row of the following series? The series is given to you in the red box here, and it is something like the first row has one number, the second row has three numbers starting from 2, 2, 3, 4. Similarly, it goes on, and it is asked that what is going to happen in the nth row, what will be the sum of the terms there. Okay, so now for this kind of a question, I would say that make use of the options. Don't go after solving the question, because in that case you will end up spending a lot of time which you cannot do in the entrance exams or your placement test. There you have to be quick. Okay, so let us try to solve this question using the options. Let us see in first case, in first row there is only one term, the sum is also 1. In second row the sum is 2 plus 3 plus 4, that is equal to 9, the sum of terms. In the second case it is 5 plus 6 11, 11 plus 7 18, 18 and 8 36, 18 and 8 is what, 26, 26 plus 9 is 35. Now I have come to know the sum of terms in the first 3 rows of my series. Okay, now I'll try to make sure that the options that fit into this criteria, the criteria for the first 3 rows, one of those options is going to be my choice. Now let us try the first option. The first option is given to us is n square plus 1. Okay, Let us try for the second row. In the second row, how many, for the second row, the value of n is 2. 2 square plus 1. This is equal to 4 plus 1. This is equal to 5, which is not equal to 9, which is the sum of the second row. So this is not my option definitely. First one is not my option. Let me check the second one. 2n whole square minus 1. Okay. Let me try to check it again for the second row first. Okay. So my value of n here is 2 because I'm doing it for the second row. Square minus 1. 4 for 16, 16. 4 for the 16, 16 minus 1 is equal to 15, which is again not equal to 9. So second is also not my option. Let me try the third one now. When I try the third one, what do I get? N cube plus n minus 1 whole cube. This is equal to, let me again do it for the second row. So my value of n is 2 because I'm doing it for the second row. 2 cube plus 2 minus 1 is 1, 1 cube. So this gives me 8 plus 1, 9. Okay, fantastic. This seems to be matching my requirement. Okay, so now I have come to understand that for second row, this option satisfies my conditions. But I want to be doubly sure. Okay, so let me try it for the third row also. What I'll do is, third row means n cube, 3 cube. 3 cube plus 3 minus 1, the whole cube. This is equal to 3 is a 9, this is a 27. 27 plus 8, this is equal to 35. Fantastic. This meets the requirement for the third row also. It means option number 3 given to me. Look at the question now. The option number 3 given to me is my correct answer. Okay. So now, as you can see, for this type of questions, it is better to use the options. Go after the options. Do not go to solve the question. Okay. Take an easier approach and this type of question will become very, very easy with that. Okay. So guys, with this we come to the end of this video. And I sincerely hope that whatever we have learned in today's video is going to help you solve the questions from this chapter in a very easy manner. If you have found today's video useful, do give it a thumbs up and share it with your friends who are trying to learn this chapter. And if you want more videos like this on quantitative aptitude, make sure that you subscribe to the channel. Okay? Because we are coming up with a lot of new videos on quantitative aptitude that are going to help you crack your placement tests and entrance exams also. See you very soon with a new video. Till then, bye-bye. Take care.